Full wide. Highlight.
Man, that's a weird. Just, yes.
Gosh, it makes me think he's a Leo. It's like center of attention. It's like I've been waiting all day for cameras. Watch this.
Been practicing my backflips all week.
Yeah.
My one moment to shine. There's looks like a worm down there too, actually, hey?
Oh yeah. Right below the porch.
Yeah.
Paleomagnetism.
Yeah, what's interesting, since the paleomagnetic orientation typically points towards the poles, either the north or the south, you can actually take cores and sometimes reconstruct how continents have moved. Because when it formed, the rocks would have orientated themselves magnetically towards the North Pole. And then as they rotate the plates through time, they're going to change. And you can kind of back calculate plate motion from magnetic poles.
That is really cool.
That's a cool looking sponge.
That's an interesting way to
like
do
a bunch
like
of grapes.
forensics of the geology.
Full eye, please.
Oh yeah.
What?
Is that such a thing, geological forensics, or is that just the research in general?
Yeah.
Okay, Roger. Can I be a geological
forensic geologist?
Yes, please.
If you can find some geological motors.
I believe that's just called geology.
Bridge
Yeah.
20 meters, 204. Yep.
Actually, wouldn't geological murders technically be paleontology?
Yeah, that's kind of paleontology. Looking at mass extinction events.
Is there an urchin there? Or an enemy, I guess.
Maybe?
I can't see it at all.
Go ahead and
Random
push on the
lasers.
midbit, please, on your screen. An enemy.
Oh,
Oh,
wow.
That's
Good
a cool
eyes.
one.
Yeah, beautiful. Oh, white, so white.
Liz was saying they
There we
wanted
go.
some urchins. I don't know what exactly they were looking for, but
Oh, I haven't seen an
Alright,
urchin
full
yet,
eye,
right?
Full wide.
Yep, no urchins yet, but if
Although it
we-
would have been nice to get that sea cucumber, but we kind of want to see more of them before we start sampling,
Sure.
ideally.
Is it common to see a white anemones? I've never seen one before.
That's the first one I've seen on this expedition.
And you've seen them before, though?
Yeah, occasionally. They're not super common.
Oh, wow. Big one.
The shallow water ones.
Are
White. Well, in the Pacific Northwest.
Matridium, white and orange.
oh, pretty.
I'm not sure. Do you guys want like kind of zooms on any type of fauna that we see? Is that
Yes.
Yes, that would be wonderful. Thank you.
I mean, overall, it's only a 2.5 kilometer
Full
or so
please.
track. So
Right.
the goal is just to go slow and look at all this
okay?
typically uncharacterized deep biome.
Sure thing. I'll get us in a good position again. Kind of got a little bit wavery there with the little sea cucumber dancing up in the water column. Thing was luring us into a trap. Another thing here. Do you want to do a snap zoom center screen? You can't tell if that's a bivalve. Probably not.
Some kind of dead something, I assume.
Roger, full wide, please.
Full wide.
Actually, bivalves, this is a silly question, but was there a depth range for bivalves? As in,
That's a great question,
is there yeah.
and I do not know.
How deep or were the hydrothermal vent fields on the East Pacific rise?
2,500
Okay.
meters.
Well, they're at least that deep.
Okay.
Go ahead and push on in there, please.
Another nice looking sponge.
Sorry, one more.
I think that's another hylamanema.
There we go.
Nice.
There's a tiny little sponge on the right.
Nice. Looks like a little dumpling.
Yeah. Now I want dumplings. Little soup dumplings will be lovely.
There is a family of
away, please.
bivalves called Thyracearidae, which can be found all the way down to hadal depths in the Kuril-Kamchatka Trench.
Bridge nav,
Whoa.
20
Interesting.
meters, 204.
Nice. That is deep.
You know that story I was telling the other day about the trench that they found on the USS Tuscarora?
Yes.
That's the trench they found.
Ah, Kamchatka.
I just find it very difficult to say with my mouth.
Yeah. It's kind of fun once you get used to it, though. Kamchatka.
I would have called it Kamchatka, because I've only ever seen it written down. I never heard it said out loud.
All right.
What part of the world is that in?
It's
Pacific?
southeast of Russia, northwest Pacific.
Oh, it's a big peninsula that comes down from Siberia.
Yeah.
All right, I knew I sounded familiar.
Something in your bubble.
Oh, yeah.
Like purple
Nice spot.
sponge looks like.
Excuse me, excuse me, excuse me.
Backing up, backing up.
It's gonna just blow right past. All right, where do we do it?
Oh, wow.
That's a cool one.
That's unique also.
Yeah.
The coloring, the shape.
Yeah,
Yeah.
everything. I don't know if I've seen a purple sponge, but I haven't seen a lot of sponges.
I like that.
I've seen a
lot of
purple
sponges.
sponge, but only at much, much shallower depths and in the family
push that in there,
Ladrancunia.
please.
I wonder if this is worth sampling.
I'm going to turn your porch on.
Let's see.
Sure.
You can tell me to not, but I think I want it.
Looks like it almost has
Roger.
purple little veins.
I'm gonna see if I can get it squared up here. Sorry, it's gonna be a little bit bouncy for a sec.
Okay.
This tilt. There, that's good enough. Go ahead and push on in some more.
Oh, look, yeah, like nice little veins running through the inside there.
Yeah, interesting.
It's really beautiful.
If you guys want a sample of this, we should probably do it soon, though.
Yeah, if we could grab a piece of this. This does look like something that's on
Bridge nav, hold position.
Yeah, Chris Kelly's wish
Chris
list.
Kelly's list.
Pull wide, please.
You think
Oh, wow.
just suction,
Yeah.
Raj?
I think so, miss.
Bridge nav, 40 meters, 045.
I'm kind of doubtful that we're gonna feel it.
Okay.
All right, this will have to be kind of.
Yep, gotcha. Just about set up.
Oh, you already flushed it.
Yeah, I did.
You rock. I can jostle that
Thanks,
while you.
yeah.
Oh, we got it already?
Negative.
Not
Or we're not
quite.
that fast.
I like
pick up
looked
the
back
arm.
up and it's gone. Where is it?
Wait, yeah, but where
It's
is
coming.
it though?
It's coming, man. Just so is the cliff. So we'll get
Raj.
it fast.
I'll just come up a bit then. And then I'll just get the arm out. And
Okay, we're gonna do sample jar 7. Sorry for the out of syncness, but we're kind of low on time.
Perfect.
Okay, I'm gonna hold here for a minute.
Raj.
I definitely need to get out in front of you.
Okay. Okay, I mean I'm ready, I think.
Okay,
Can I get a zoom on that and a bump up on the camera?
Chris, you can go ahead and arrest that backwards move. Let's not. We're not
Bridge
gonna
nav,
feel
hold
it.
position.
All right, we
Okay.
got 60%. Maybe
Roger.
a little less. There you go. That's good. Nice. Solid.
Excellent job.
More or no?
No.
Science?
Ah,
I think that should be good.
Okay,
Yeah.
just
Yeah.
checking. Okay.
Yeah.
Kind of come
Zero
wide on
now.
the HT.
Well, it's pretty,
Beautiful sponge.
you guys happy with the amount? It kind of, it's really delicate. It looks like it kind of blendered itself. Oh, there's one good chunk.
Oh, there's a good chunk in there, yeah.
Okay.
All right, awesome.
Yeah, these ones will be really delicate. This is probably a glass sponge, and so that it won't get any better if we try to grab it. It'll just fragment.
Gotcha. Should I be turning off the craft power and valve when we're done with it, or do we not need to do that?
We can just turn off the valve.
Okay.
Yeah.
I'll put power back on then. Sorry
Roger.
about that.
No, you're good.
And I'll give you a different camera up there.
Danke.
And I'll give you the porch back. And I gotta do a gauge check. Housekeeping.
And I gotta run.
For those joining us at home, we're on a deepest dive of the cruise, and we're currently around 3,800 meters, which is about 12,500 feet. So quite deep. Seeing some interesting
Coming up.
critters.
Raj. When
Bridge
you
nav,
get
20
ahead, I'll
meters,
take your gauges
204.
in, yeah.
Yeah, sounds
Roger.
good.
Thank you.
Sorry, I'll keep a better eye
Got
on
a
that.
black coral on the right.
No worries, yeah, when we switch salvos, it, you know,
I missed it.
absolves.
Oh. I think it only appeared in the still cam.
Oh, there's something coming up in the stoke cam, a
Yeah.
little coral right ahead.
We'll get a view of this next one.
We ran out of map.
Roger.
Oh,
Right
there
on
it
the
is,
top.
top right.
Top right, Raj. Yeah,
We gotta
we're
scoot up the hill to catch up.
we gotta scoot up the hill, but
Yep.
I think we have a second if you guys want to look at this one.
That'd be great. Got a snap zoom.
I'm gonna try and turn down my spiciness here. Go ahead and push on in there, please.
Is this another Chrysogorgia or?
Tina was saying that this looks just like what we just
Go
saw,
ahead and
that
come
it's
partial
a
white.
species of primnoid that has just a single row of polyps.
Ah, cool.
She gave us a
Sorry.
nice link to the description paper in the
Oh, yeah.
chat.
I see.
You guys want a different zoom on that since that one got occluded by a bunch of my thruster wash?
I think that one was fine.
Yeah,
We
looks like
can
it
keep
was
scooting.
Pull away, please.
corrected on a few different seam mounts.
So are the scientists ashore keeping the same watch schedules?
We've got the two scientists ashore who are chatting with now. One is in Japan, and I think one is in Russia. So they're on a more convenient time schedule than, say, colleagues on the East Coast or the West Coast.
Yeah. And we are very thankful for them.
Yes.
They know a lot about corals. And I know nothing. Meredith knows a lot, but that doesn't stop me from trying.
So, Chris, you're saying that we're out of map for this part, right?
Yeah.
Do you guys want another part of map, or?
I think we can go ahead a bit,
Okay,
yeah,
roger,
and try to get it.
roger that.
Because I think it's, what was it, 100 meters, 180 meters you got radius before?
Yeah. Yeah, so these spirally maps are not going to be the best quality, like a final product. They're good for sort of scouting ahead and stuff, and they'll get you something.
Right.
But if you want something of better quality, we should do a tether length survey.
Average. Okay.
Although we can see a lot further with the circle ones. So if you're just looking to get a general idea, that they'll work.
Okay. Got a little shrimp
Roger.
hanging out
Thank you.
in the top.
Oh yeah. Did you guys want to look at the shrimp?
No.
All right. Yeah, we care about the corals and sponges. We don't care about the shrimps.
Yeah.
No offense to the shrimp.
They'll get in front of the camera regardless if we wanted or not.
That's right.
Is that just because they're found everywhere, or really because this?
For me, it's because every time we've seen one, they always look the same. If they start coming in different colors, I'm all for it.
Kevin, are you seeing anything different in this rock formation than the one where we landed, or is it sort of more of the same?
I think it's more of the same. It's hard to tell from here. But you can kind of see the areas that aren't broken off, how bubbly and ferromanganese encrusted they are, and the areas that have broken off are quite angular.
So the reason for going up in between the gully, or in like in this valley between the two versus along the
20
slope,
meters, 204.
on the steepest slope,
Uh-huh.
is that because we're expecting more sampleable rocks here?
Yeah, there's more sample rocks, but also it affords us the ability to kind of swing back and look at both ridges and see if
What's
one's
this
better than the
thing?
other.
Yeah.
Kind of gives us a
push on in.
little more view.
I see.
Whoa, what is this cool thing?
It's a fish, and we're just getting it from the tail end.
Oh,
Really?
funky looking fish. Also doing backflips.
Interesting.
I don't know. Can we zoom on this? Is that a coral or is that just
That's a
debris?
worm. I think that's a worm.
Oh, it's a
but
worm.
let's find out.
Exciting.
On some porch.
Yeah. Thank you. Go ahead and push it in there, please. Oh, it's a... I don't know. I don't know. Get a little more zoom. Ugh. guys. That's just the...
Could also be a cast.
Is that a sea dandelion? That's a sea dandelion, isn't it? Or is it trash?
That's trash.
Are you sure? Can you lie to me?
I think that might be a cast from
There's
an ecinoderm.
ecinoderm over here on the left.
On the left.
Yeah, sticking right here on the rock.
Oh, the little.
Oh, yeah.
Oh,
The little
wow.
purple guy.
Hope you're right.
All right, full right, please.
Full wide.
Porch off.
Oh, yes, please. I wonder if maybe we can change the camera angle and the porch will not give a glare. Should we try?
What?
Go ahead and try putting it back on and then... So it's only up here that we have a glare.
Bridge nav, 20 meters, 204.
There's some thick ferromanganese crust there.
Oh, yeah.
Okay, so the sort of the smooth looking rock is the
Yeah,
crust.
all this bulbous smooth rock over here. And you can kind of see where it's breaking off because it's such a steep slope, just kind of going downhill.
Go ahead and do a partial zoom there, please.
Partial zoom.
That's good.
Does that mean that some of this broken up rubble we're seeing might just be broken up crust?
Yeah. There's also some tracks on that ferromanganese from some critter.
Yeah. There's so many different textures in this frame.
Yeah, it looks like it started off kind of botryoidal and then got smoother and then broke off. Generations of ferromanganese.
Yeah. Go ahead and come wide, please.
Come on. Cool.
Yeah, it's very lumpy. There's more tracks. Remix.
Can we zoom in on this potentially dead sponge? I don't know what it is.
Yeah, sure thing. Go ahead and push on in there, please.
Sorry, that's it.
I think that's actually just marine snow sitting on the seafloor.
There's a big aggregate of it.
Yeah.
No,
Yummy.
it's a ball of snot, probably.
I'm sure some local detritivore will think that's delicious.
Go ahead and push on in a bit more.
It's made up of all. It looks like it's made up of all kinds of little globules.
Dramatic exit.
I don't know what.
Wide, please.
Dryer lint.
Watching it blow away in the breeze.
Cinematic exit.
Cinematic exit of the snot.
I have 20 minutes. It's okay. Not used to sharing. Oh, blue water. Oh,
Bridge nav, 20 meters, 204.
that's all right. As
Can
long
we
as you're
zoom on
feeling
this
good,
white?
I'm happy.
See what that is?
Yeah, sorry, the little
It looks like a sea
star thing.
Yeah.
Oh, there's two.
Oh,
Oh
there's
my
a bunch
God,
of
there's
them.
3.
And they're adorable.
And they're definitely
Where?
adorable.
These wee ones.
Oh, little babies.
So whichever one's easiest to zoom on.
Sure thing. And get us stable because they are very small. Little constellation. Go ahead and push that in there, please.
Wow. 1, 2, 3, 4, 5, 6.
Now, could these be a slime star or,
Are the cookie ones?
yeah, cookie cutter stars?
Is that full?
They
zoom in
could be
there?
little
Just
tiny
all the way.
terasters.
Roger.
That's what I call my nephews.
Cookie cutter star?
No.
Terasters?
Yeah, I don't have nephews. It's all for the jokes.
You have to spell that with a P, though.
Boy, please.
Another one of these biologies with silent letters.
That joke will never not be funny now. Like,
Silent
make
P.
the joke and then follow it up with a grammar. You guys all have really good eyes. I feel like you'd make good hunters or something.
I didn't see that.
Yeah, I was
I didn't spot those.
You're like, you said zoom, fine. You can have it.
Just a heads up, if we see more of those, we got a call for collections of those sea stars.
Yeah, we do. Cool. Kyle is ready for the
Eyes
slurp.
peeled.
There's another, oh, never mind. There's another sea star, or can we have a zoom on the lasers?
Yep. Go ahead and push on in there, please.
It's another one of these light-colored, oh, look at that.
Little tiny brittle star.
Yeah. Needs more corals in the area for it to hang on to.
Very cute. I think you can see the little star inside of it, too.
Yeah.
Full wide, please.
What?
There's a species of brittle star that forms the most perfect natural lens formed in nature over its eye spots on the end of its arm.
Wait,
Yep.
who figured that? Who
Yeah, we need more
figures that out?
clarification here.
Like, that has to be tiny.
It's very tiny. There's some pretty impressive SEM photos.
There's another one of those stars, I think.
Cool. Oh, yeah. Maybe.
I didn't know sea stars had eyes.
They have
And I
eye spots.
certainly didn't know that they were at the end of their fingers. Arms.
Yep. Even
Toes.
the big ones you see at the beach, if you look very
Good
carefully
push
at
on
the
there,
end of
please.
each arm, there's a little eye spot.
Eye spot.
Oh, no, that's not one. Never mind.
Roger,
That's
full
a
wide,
hold
please.
fast from a sponge or something. Tricked me.
All right, I'll get out of bed. It has the most perfect lens.
Yeah, like just from the optical properties of it, it would be it's this really delicate crystalline structure, and it's one of the most perfect lenses formed in nature, and no one knows why they have it because their eye spots basically
I just
detect light and dark and
Yeah,
can't,
gotta
but
push
it
that
would
in.
form a perfect image if it had like an optical nervous system.
So, okay.
Oh, cool.
I'm glad you
isopod.
mentioned I'm glad you said what you said
Oh, yeah.
about what their eyeballs can do.
Did you want to look at the isopod before
Yeah,
we go?
Oh, is that?
Did you want to look at the isopod before we go?
Yeah.
All right, go ahead and push on in there, please. Do a bump up.
Neato. Thank you.
It's a scale worm.
Sorry.
Ah, scale one.
That's full.
Yeah, Raj, it's not very good on my end. Sorry. As soon as I get it in frame, we're ready to go. So go ahead and come partial way, please. Okay, try that again.
Zoom it in.
That's no better on my end. Sorry. Full wide, please.
Full
Yeah.
wide.
Thank you.
And a shrimp.
And the shrimp.
Of course.
Is it a seastar up there, straight ahead? I just had a frame. Oh, no, sand. Never mind. Discard.
Sandstar.
Spectator shrimp.
Very small ribble talus.
Yeah.
Yeah, very fine over here.
Bridge nav, 20 meters, 204. Yeah. I can do this all night.
Why is the lighter color rock distributed throughout this area the way it is?
You mean these guys? Like this? I think that's just actual accumulation of sediment between some of those samples. So it's mostly this kind of basaltic gravel, and then some areas, for whatever reason, it's slightly less steep, guessing. It's accumulating some carbonate sediment, marine snow. Is that a star over there? I'm going to interpret
double
every
pressed
white
SPL
dot as
there,
a star
Jess.
right
No,
now.
we're going to be chasing
Oh,
stars for the
sorry.
rest of the watch.
I double, yeah. That is not.
No.
No. Hold fast.
If you're thinking you want to do that other map, we're probably getting to be about that point. So we have a little bit of overlap with the last one.
Yeah, I think now's a good time so we can do it while Chris is on board,
Yeah.
on shift.
Sure.
Yeah, I'm probably going to stay on board.
Please
Nope.
stay on board.
You served your
Chris.
purpose, we're going to toss you.
Do you want me to come up in the water column?
Yeah.
Like 10 meters or so?
Maybe
That might
20.
be also a sea star
20
though.
meters? Raj. Yes, Raj.
I'll look at the screen to see how I can widen the swath too.
Okay.
I
That
can
is a
spot a
seastar.
seastar from a
Good
mile
eye.
away.
Did you get? Do you guys mind if we do the map, or would you like the seastar first?
They wanted to collect it, so
Yeah.
Okay.
whatever's going to be. If you can come straight back down.
Well,
No.
we're never finding that sea star again if we do that.
Yeah, if you're going to go 100 meters up or something, yeah.
No, we'll just be like 20 meters off the surface, and then by then we'll have traveled a little bit. So
Yeah, I say just grab the seastar first,
Yeah.
just to be safe.
Looks like
Roger
there's
that.
another one off to the right there, a little bit farther back.
Yeah, I see.
all right, Kylie. Your seastar will be served to you by Miss Kylie. Sorry, you're not lined up on.
Okay. My craft valves on.
My goodness. I'm gonna need a minute to get you suction.
No problem.
All right. All right, we're thoroughly flushed here.
The jaws are good for everything except grabbing the slurp.
Really, yeah.
Yeah, you know.
And not, that's not even the only thing. Give me it.
They make it really hard to count on your fingers too.
Can you telestrate it for me when it's, yeah, oh, is that little thing?
Yeah, it's the we.
Wow. Okay.
Yeah, we wouldn't have found that one again.
You can drop a target, it ain't gonna change. Oops, sorry.
All right, I'm settled here.
Okay.
All right, suction coming on.
Can you push in for me? Thank you. Good.
You got full jam.
Hold on, I need to just re-index.
Roger. I'll get you a bubble.
Okay. Bubble's awesome right now.
Yeah, bubble's our only friend.
Okay.
Want me to come a little wide and look up a little bit?
No, I'm okay. I'm gonna index and just get comfortable.
Yep.
Oh yeah.
Nice.
Give it to me. Please, more suction?
It's 100%.
Oh.
You might just scrape it. Yeah, there it went. Full
Oops,
wide,
sorry.
please.
Yeah, please wide. Huh?
Oh yeah, so you already put the slurp away. Good job.
Yeah. Just like I meant to do.
Have you guys seen it come through on the bucket cam?
Negative.
I have not seen it.
Just keep the suction on, yeah? Maybe he's going for the ride. Maybe he's in the
Oh,
suction.
sorry, I didn't realize I had zeroed it already.
You're like so on it.
Was that it?
I didn't say anything.
There
Oh,
he
that's
is.
it.
Oh,
Okay.
perfect.
There we go. I was like reaching over for that to see where the arm was. It's
Yeah.
so wee. Very cool.
Which slurp jar did that go into?
Oh, number 6.
Wait, sorry, what was that?
Number 6.
Oh, okay, cool, thanks.
Plenty of space to add a coral in there later.
Yeah, totally. Oh my gosh.
So the same slurp jar. Roger.
I mean, you're not going to confuse a coral with a star.
Then maybe we get that predation study sample.
Ooh. Ooh, in situ.
2 birds on stone.
I can note that on the dive sheet for the next watches. Should I write on there that they can put another coral?
They might actually just like know rotating through the jars that there's something tiny in there. Or you can just make a note that it's a tiny, tiny star.
Roger. That's good.
All right, we going up?
We are, yeah, I'll ascend a little bit. And then
How high do we have decent DVL?
I think that was like 80. Well,
Okay.
that was like 1 beam. I can just go up to 20, unless that would
Yeah,
make
20
a
is
smaller
probably
spot.
yeah, 20 is probably fine. We're gonna get better, do better if we can keep DVL.
Okay.
We did that last one very high, but we were doing it for different reasons than to make a pretty map. So
Roger. All right. Roger. Thank you. Okay. All right. You want to come? I'll start ascending in the water column a wee bit, and then we'll do the dance. But, oh. I don't know. Do-do-do. And you said out of auto depth, correct?
yeah, yeah, auto depth is way too heavy.
For those tuning in, what we're doing right now is pulling up above the seafloor, and then we're going to do some fine-tuned mapping of the region using sonar that's attached to Hercules. It's kind of new technology being developed over here by our navigator, Chris. And it's been really awesome so far. We can kind of just make circular maps of the region as we go.
Kevin, I think we should just prank it and be like, oh, that's the end of the dive.
Yeah, exactly. Thank you all for coming. We got the seastar.
Yeah,
Mission
We're gonna
accomplished.
recover. It's a long way to go for such a tiny, tiny thing.
All right, I'm at 23 meters altitude.
Can we do another 10?
Roger. Coming up some more. They're
We
gonna
need-
think that we had like an emergency with the wall.
Yeah, I should turn around. I should we could show tail to tail, make it look real.
We need to make sure that the 4 to 8 watch gets a little bit of blue water time, at least, you know,
Yes.
at least 2 to 3 minutes.
At least a few minutes.
Yeah.
Yeah.
Heck, we can go up to 100 meters.
All right, this looks like this is going to give us a little over, pretty close to 100-meter radius. Are we
Sweet.
still, what altitude are we at? I guess
32.
I guess I can figure that out. I have technology for that.
Yeah. I think you have the means, sir.
We
Little
could
higher?
we could do this. We're not. We'll get a little bit of overlap. Yeah, let's try this.
Okay. All
Venn
right.
diagram.
I just don't want to make this a whole thing going way up. So
34.
so yeah, just do.
Yeah, so it's at one degree per unit.
Oh, you can just tell it to do that. Okay.
Yeah, so I
I didn't
can
realize
select.
that. All right, recent points. Let's turn that on so we can see what we're doing.
So I'll just aim for 90 and then, yeah. Sorry.
Yeah, we're not going to get a ton of overlap, but that's maybe okay.
Raj.
Gonna be some brutally cold water for whoever's retrieving the rocks out of that bio box.
Oh, yeah.
Ooh, that's a good, yeah, good point.
How cold is it?
1.45 degrees C.
Gross.
See, I just love it when new data lines up with old data. Just like, it means that things are going well.
Yeah. I was going to say you can import that into Chimera and do a matching, but it looks pretty good.
Yeah.
You just captured the feeling of all scientists. It's always good when new data lines up with old data.
Yep.
Although sometimes it's more interesting when it doesn't.
Makes for manuscript reviews to be very difficult then, doesn't it?
Yep.
Gotta like keep cranking the range on this. We keep getting, the Norbit can see really far.
Turn it up to 11.
Yeah, so we can't see upslope very high, I guess that's to be expected.
Yeah.
We can see downslope a lot better than we can see upslope.
For those tuning in at home, camera 3 has the view of the sonar being actively taken, if you're interested.
Yeah, but you can see here this valley that we've been traveling up, right? The base of it there.
Yeah.
So, yeah, so for future reference, if we want to do this more in the future, if we want to be able to like see more of where we're going, we got to go a lot higher.
Okay, roger.
So,
I
which
guess my
in
altitude
hindsight
dropped.
makes sense.
Checks out.
You just need another Norbit upside
Yeah.
down on top of it.
Yeah. Well, we can mount the Norbit forward. Ooh. And then let's do another pass going the other way because some of the points are a little thin.
Roger.
Or actually, can we go up for the rotate back? Can we go up another, I don't know,
10 meters?
10, 15?
Sure.
That'll be an interesting data point anyway for, we're almost done, have almost done the full circle.
Yeah. Roger.
Yeah, you can see this one's is not as sparse or is a lot more sparse than the last one.
Yeah, roger.
You can see, I mean, it's a similar radius, at least downslope, but we're really struggling to get those outer points.
Okay. It's okay if I lateral and stuff to get...
Yeah, you can move around, that's allowed.
Cool. Okay, all right. I'm starting to come up here.
Remarkable.
You know, hold there or keep going?
Yeah, Chris, 50 good, or do you want...
50 is fine. I don't want to go too much higher than that because then we're just going to lose DVL, so.
Okay.
Roger.
How high did we do? The last one the first one we did very high, right? We were
Yeah,
at like
yeah.
150 or something, or 180, something like that.
Yeah.
Yeah.
Yeah, but that was too high because we didn't have DVL.
All right. I'm going to go back the same way I came, just so
Okay.
my tether wrap.
Yeah, you can rotate whichever way. Just keep it slow.
Yeah, the velocity is the same.
It looks like you're going quicker though. Or are you? I don't know.
Negative, same velocity. Want me to make it smaller?
Yeah, a little slower would be good.
Is that an alright speed for you guys?
Yeah, this is good.
Okay, 0.7.
Yeah, once we get high, the ping rate starts slowing down, so you got to be careful not to spread them out so far.
Roger.
What's going on?
That too. What was that?
Good morning, good evening, and good night, depending where you are in the world. We're just going through another watch change, moving to our 4 to 8 team, aka Team Watchbucks. And we're going to hopefully answer all the questions that you have in chat at our earliest convenience. For those of you just joining us, we are doing a little bit of mapping with Hercules in Atalanta. Just spinning around the place and just getting a feel of what our ocean floor kind of looks like. And hopefully mapping out an area where you can go collect more samples.
Okay, wow, I'm really rising up here. Way down in the distance is Hercules. It's all right.
So Brandon, first question of the day coming from myself. When you see all of this sort of, these kind of rock formations that we see, what type of flow would we consider that? Take your time.
I guess sheet flow, probably. It looks pretty fine.
Really?
Yeah.
You wouldn't consider this a pillow flow?
No, I would not. There's no, like, I guess, z-axis, like, dimension to these rocks that you'd expect from a pillow flow. Yeah.
Gotcha.
All these rocks look pretty thin.
So why does it have
we've
that
seen so
sort
far.
of pattern that we see, or not pattern, but that sort of it kind of like breaks up like that?
Right. That's just probably like the lowest point on the slope. So when little chunks break off, they go down that little, I don't know, crevice, I guess. That little depression.
There we go.
So it looks like it's a different pattern, but it's probably just covered, would be my guess.
Oh, I'm getting pulled around here. Come down a little bit, yep.
But I could be wrong, and it could be something else.
What would that something else be, would you think?
I don't know. It's not coming to me right now in this early morning.
For those of you just tuning in, it is in fact 4:06 in the morning on Hawaiian Standard Time.
There's some sort of stalked creature in the upper right if we have time to zoom on it.
Ooh.
Plan for the dive is we're gonna keep following the track that the last watch set for us. Some angular stuff over here. They collected a number of things, some sea stars.
Tether's tight.
There's a couple of things here. There's a shrimp off to the right too. Must be a good flow here, yeah.
So Faraday?
You know, at this depth, I don't know. We're kind of really in like totally new territory, so we have to look at these a little bit more closely. There's a nice rock to the right too when we're done looking at this. Yeah, if we're gonna sample
Might be too big.
A rock here, can we sit down and collect a piece of this sponge as well as a rock?
Back sim.
Is that too big? Yeah.
Yeah.
Oh, that one might
Okay.
be too
There's
big.
one in the back I see as well.
Yeah.
Oh, wow. Craft comp's up at 5.5.
So Steve, this stock something, is this considered to be a sponge, it looks like?
Yeah, it looks like some sort of sponge, maybe a glass sponge. But I think our sampling interests are more broad on this dive versus other dives, only because this is the first and deepest, well, this is the deepest dive to ever occur in this area, in this monument unit, to the best of our knowledge.
Yep.
So anything we collect here is probably not been collected before, or if there's been deeper work done, it's probably from a far and adjacent territory, something like that. So it's worthwhile. A lot of the things, even if we were to look at them on video here and try and identify them using the best specialists in the world, probably wouldn't be able to identify it beyond maybe a family or at best a genus. But with a specimen, we can often arrive at a better identification.
So how deep exactly are we?
We are at
about 3,742 meters.
Whoa.
So about, we started off our first dive of this expedition at 3,200, but we're still seeing different things here. So about 500 meters deeper than our deepest, but it makes a big difference.
So what are we seeing that's different here versus the other types, other expeditions?
Mostly just interest and scientific objectives have been different here versus on other cruises. So that dictates where folks would typically dive.
Coming up.
We sort of want to characterize this ridge that we're on. I think it's east-west trending, and it's clearly not of the same origin as most of the seamounts in this area.
Coming up again.
Because it's such a skinny ridge, and
Nice.
Great. On either side, there's
Can you see what slurp jar that is?
Say again?
Can you see what slurp jar
the land
that
mass is lower.
Yeah, that's
I can't remember
like
the scientific words,
Five.
but they're not coming to my brain. But
Thank you.
there's faulting on either side, so it looks like an uplifted ridge where the other seamounts are volcanically.
Yeah, that's 5.
Sweet. Thank you.
Oh, you want that rock?
That's a big rock.
It's a good looking rock.
Does that rock fit?
Dan, you might not be on SPL or muted or something. I can't hear you.
Sorry, thanks. I just picked up that rock because
Gotcha.
it was
How does
loose.
it look?
You happy with it?
If it fits, it looks good, but
Yeah,
it will fit. Yeah, this will go in E or F, I imagine.
Yeah, it should do. Did you get enough of a video of it there?
Got screenshots of that.
Yeah.
I can real quickly highlight it.
Did you guys get a still there?
Yep.
Yeah.
Yep.
Okay. Put it in the box. Just rub it across the hill there. Come on, Herc, come up. You can open the box.
Coming out.
That is correct.
Is that good there?
Yeah, it should do. Oh yeah, plenty of room in there for more rocks.
Awesome.
Box E. Sweet.
Okay, you can hit 5 on the
Box
nip bit.
E.
Nice.
So,
Strong start.
What's that, man? Okay, Lynette, you can kick the ship into gear. Let's go, go, go.
So Brad, are these smaller rocks around
I
there?
still didn't get it. I'll have to try one more
Are
time.
those,
Sorry.
would you say those are like nodules, or would you say those are just more just smaller versions of basalts?
the smaller versions of basalt.
There it is. Come on, stupid thing. Got it.
Just like
Finally.
pieces breaking off.
You're aware I've just got the forward thruster, Dan, right?
What's that?
I've just got the forward thruster on Atalanta.
Oh yeah, I'm highly aware of that.
Okay.
Oh, here's our first question from the chat, actually. So would it be worth a potential collecting of a bit of these shmoo, quote-unquote, chugs floating around and do some eDNA on it, just to see what it might be or what it consists of?
Yeah, the marine snow. You know, I think if we did take a water sample, it would almost certainly collect some of this material anyway. It's very hard to target it. If you were to slurp something like this, it probably wouldn't stay in the jar. It would probably get sucked out because the filters are only 3 millimeter, so something could easily pass out of the filter. But yeah, if we ever take an eDNA in this depth,
Zoom in on
which
that
is
guy. if you want,
likely,
yeah.
Yeah.
there we go. I think this is a euplectellid.
Sorry. Okay, could go in.
All right. Not sure if this is
Full screen that sonar
crust
for us.
growth right here, or it's a little outcrop. I guess it must
Ditch
be
the,
a combination of both. Okay.
Thank you.
So, nav.
Yep.
Our dive plan says 10 hours, and I didn't get any specific instructions that we had yet planned to extend the dive, but I think we're probably going to need more time on the bottom because, let's see, 10 hours would put us back on deck at 9 a.m., is that right?
10.
Yeah, because
Yeah.
we started at 11 p.m.
Yeah.
Okay. Yep. Yep.
So I'm guessing that would mean probably a 3 or more hours of ascent, which would mean that we would have to come off bottom sometime in the middle of our watch.
Yeah. Let me double check that.
Yeah, let me know. Let me know, because I think more than likely there's room in our dive plan to extend,
Okay.
but we can reevaluate the decision when some of the other geologists are awake in a couple hours.
Sounds good. I'll take a look at the ascent time and how long it's taken us to get along our track here.
Cool. Thank you.
Yep.
Hercules gauges look good.
Roger.
So, what's the
After the desiccant change, Atalanta humidity is 60% lower. Down to 5% humidity.
Yeah, those disc packs really do work.
some possible feeding traces maybe here. Don't see any animals though.
You want to zoom in there?
No, just pointing it out. Looks like there was something mucusy that dragged itself across the seafloor there.
Bring your head to the left a little. We'll follow this little thingy here for a while. Am I pulling on you there?
Yeah, either you're pulling on me or my thrusters are having a hard time.
I'm probably pulling on you there.
Want me to let Atalanta catch up?
What's that?
Let Atalanta catch up before we do another ship move?
No, you can move.
Okay.
You can speed it up a little too. Can do 0.3.
Poor forward thrusters having a real go.
I'll drop back down there so you can.
Thank you.
For our
This
viewers,
very fine gravelly stuff.
For our viewers at home, if you want to you could switch on over to channel 2 and you can actually see a really nice shot
No, it doesn't.
of Hercules looking down on the ocean floor that you're seeing.
My guess, and I'm not an erosional guy, the slope at these points will only accommodate that size.
You can come
where
down a
larger
bit if you want.
sizes move
Come
somewhere
down on
else
top of this.
where it's a bit less steep. But
You want me to come down a few meters?
yeah,
Yeah, come down
it
that
looks
far.
like there's either very sluggish or very slight current, but there's higher, kind of more stuff in the water column, greater turbidity. I wouldn't call it turbid, but there's definitely a higher density of these marine snow particles. We are in a bit of a canyon here, not huge, maybe a kilometer across, something like that. So that's characteristic of submarine canyons. They tend to concentrate and accumulate a lot of particulate matter in the water column. But this is probably just a small valley or cut in the side of the ridge that we're diving, not necessarily a true submarine canyon. And typically when you get to the walls of the canyon, you get current flows that are accelerated around the topography that juts out into the flows. But I think it looks like most of the stuff here looks like it's probably heading downslope and quickly, surprisingly. For our models suggested something like 0.5 centimeter a second flow, east-west type flows. This is a little unexpected, so it might be locally driven flow patterns here.
Can zoom in there.
Yeah, we can zoom in on that little gelatinous thing on the bottom.
Pilot
Looks like a
induced
sponge too.
oscillation.
That one might be a ferrid.
Yeah, no worries.
Has characteristics of that. FARREID for AE
full zoom.
Ferriidae. Nice. All right. Screen grab and out.
Did you get it?
Got it.
You make a note in the red book that it's time to revisit the camera speed. I need to adjust it. It's ridiculous. At this depth, still going this fast. We can
So
get it
Steve,
better
you
than
said, what was it, half a centimeter per second was the flow of this, was the speed of this flow?
Yeah, what did we say? Let me look back. I think it was... Now we're seeing some pillow flow. Small pillows, but pillows. Yeah. Something like 5 centimeters per second.
5 centimeters? Is that very fast for this kind of depth?
Known issue.
It's pretty sluggish,
happy to leave
but
it out.
for deep sea current speeds,
We usually operate with Atlanta
not outside the range of what's typical.
Than,
what is typical?
Depends on the current, the depth of the current. Depends on the substrate, what's around us in terms of large topography.
What's that?
It's not unusual to get currents sometimes up to 1.5 knots or 2 knots, which is very fast when you're in some of these larger oceanographic currents. It's great for biology. Bad
Steve,
for ROVs.
I have some information for you when you're ready.
Oh, right. Let's hear it.
Okay, so we're super deep right now. If we were to come up from the bottom here, it would take over 4 hours to reach the surface. So that means we would have to come off the bottom a bit before 5 a.m.
Yeah.
Yeah, if we make it a bit shallower, we can have a little more bottom time, but probably not a ton.
Yeah. Well, that's good. Good knowledge to have. I think that puts us in the realm of extending the dive at least, I would say at least maybe, we'll decide how long to extend it, but I don't think we're going to be coming off bottom anytime during our watch.
Okay.
Yeah, that's good news.
All right.
I just have to follow the follow the dive plan.
All right. Awesome. Sounds good.
Dive plan said 10 hours, so I just wanted to make sure that we do our due diligence.
Mm-hmm.
Yeah. Came all this way. We might as well look around, Steve.
Yeah.
That's an Okeanos dive plan, 10 hours.
Answer a question in chat. Why is there no depth for Hercules in Atlanta showing on screen this morning? If you go to our website and you click the More Data tab, it should show our depth for Hercules and Atlanta. Atlanta, sorry. Just click that little tab and then it'll give you to some real-time data graphs as well as some other cool information if you're interested.
Oh,
Some kind of other glass sponge. Probably pectellid.
Oh yeah, what do I got there?
Go ahead, Dan.
Oh, it's a stalk tunicate.
Oh, wow.
Wow.
Yeah.
That is a big tunicate.
Yeah,
Big
they are
mouth.
huge.
Looks like it's got a mouth.
And this one looks like really old. It's all fouled. But yeah, that's a stock tunicate. You see these from time to time. I think it's Culeolus.
I'm going
Is the
to come
name?
up just a bit here and get it in the DSC, so
Or that is a tunicate, and I'm confusing them. But yeah, it's a stock tunicate. Has a one opening is where the water flows in, and another where the water flows out. And all the particles are captured by the internal anatomy. Yeah, Culeolus is the genus. C-U-L-E-O-L-U-S.
I got good pictures of the DSC.
Nice. And that's the genus or the family of the tunicate?
That is the genus.
trying to get it in the DSC and the big camera, but not having luck there. It's too steep. Looks like that one's been around a while, eh?
Yeah, this one looks like it's been around quite a while. When they're a little bit fresher, they have yeah, definitely more translucent.
If you zoom out, I'll see if I can get it closer in the DSC.
So then, how old do you think this is? Or is it just, it's just too hard to tell?
Oh, I lost it.
Difficult to tell. It's entirely gelatinous. I don't know if there's any datable material in there. You know, it's a solid material that could be datable.
Are you full wide there?
Yep.
Okay. Moving on.
Is this all kind of like rubble field?
Yeah,
Yeah.
it seems like it. It looks like when it gets pillowy like this, those are connected.
Yeah.
But otherwise, yeah, rubble field.
How sluggish shark is at this depth. What's the water temperature here?
What is the water temperature here?
Same.
1.4 degrees C.
1.4.
So, Dan, Delta Dan,
What's
is
that? Yeah.
Is it, does water temperature have a direct correlation with how fast herc can move? Or is it just the pressure?
It's both.
Really?
The oil becomes thicker with the cold temperature and the depth. The pressure and the depth. Motor is electric motor is less efficient, and the pump is less efficient.
So how do you compensate for that? Do you just do more, you put more power into it, or do you just move at a slower speed?
Yeah, I'm flying at 100% here, and a lot of times we'll be at 50 to 70%.
Now that you plateaued?
Giving it the beans is one of our longtime herc pilots would say. Zoom on that guy if you want.
Oh, okay. Alrighty.
Not sure which family this could belong to. Any way we can get around the backside on the way out? Take a good peek.
Look on the bubble there, Dan. It looks like a jelly or something.
Yeah. Good eye.
Sorry.
Yeah, I can try and come around the backside. It's pretty steep, so
Yeah.
you come around the side.
We got some photos of it. It's just with some of the sponges, it's hard to tell based on a front-only shot.
I might be able to get that DSC on sideways a little closer here.
And to really quickly answer that question in the chat, so does that mean for creatures made of non-solids, you'd have to watch one grow and guess how old the others would be? Yeah, just about. The other day we actually made the analogy of you have to get a boat, sink it, watch the sponge grow, and then come back every year to actually truly date them.
So this might be Caulophacus, based on how it's attached to the back of this
zoom in there then.
stalk. That's helpful, thanks.
All right, moving on.
Another quick question in the chat. I realize this is all very dynamic, but is there any way you could put a scale on some of these features and critters we're seeing? Like how big those little stars are, for example, or how big the claw is on Herc? Well, usually when we're flying Herc, we have, if you notice, there's two little green lasers that we usually use, and those meters are about 10 centimeters or 4 inches apart from each other. So we use those to usually scale everything. So if you were to look and see those little green lasers, you can see just about how big things are on the bottom of the ocean floor.
There's also some tape marks on the jaw that are ½ inch each. Orange and red tape marks.
Oh. So there you go, viewer.
They're looking a little raggedy. We need to put some fresh shiny tape on there.
How often do you have to replace the tape? Because I know it's underwater a lot. Is it a special kind of tape, or is it just regular electrical
just
tape?
common colored electrical tape. They're I put it on there on the last expedition, and it's been on there for 10 dives or so. It gets scraped off when we're scraping the jaw around on the rocks and the bioboxes and such. That colored tape that's on the craft manipulator that you see when we do a white balance has been on there for ages.
How long?
Years. Tape holds surprisingly well for.
Thank you.
Zoom in there if you want.
Sure.
Another eupectillid?
Maybe. You can see the fibers at the base. That tells us that might be something different.
Like a polyopicon, possibly?
There are other families that have that fibrous base. So I'm going to take a look through because I don't know right off the top of my head. Could be a rosellid.
It's Max.
Take a look.
Okay, can zoom out.
This is where sponges get confusing. They don't have typical morphologies. So you have to look at certain characteristics and see which ones align mostly with the groups that you're that you know something about.
And then for Brandon, this sheet flow, do you see any, like would this kind of sheet flow, these kind of flows, where would you most notably find your nodules or the other kind of rocks that you're looking for? What type of flows are you really keeping your eye out for?
As far as I'm aware, the flow type doesn't matter for nodules.
Oh, really?
Yeah, because nodules aren't volcanic in origin. So the flow type isn't going to matter. It's more about the landscape, which I guess can be part of flow type. So I guess sheet flows be more flat.
Ah, so
you define nodules more likely there, but I'm not 100% on what environment nodules like. I just know they like deep and flat.
Yeah, this is the only boat on the planet that runs those things faster than 1.8.
Our best bet to go find them?
No, they're too shallow.
We have some unique ideas on this vessel.
But that's as far as I know. I don't do research in nodules or anything like that. My
you don't.
Knowledge base is pretty superficial, but
looks like K2's map.
And I also like to
Minecraft
remedy
when
that
it's going
I
that
think this
fast,
is
you
actually
can't get
pillow
any details, and you
basalt
miss
flow
a lot of
Okay.
and not sheet flow.
you miss a lot of features. I use it to
The
steer to
fine-grained
interesting,
sediment confused me at first.
you know, reliefs and such. That's usually where we find the critters, but when it's going fast, it's just all big pixels, so I can't tell what's out there.
Then to answer that
I've
question
been looking
in
at
the chat,
that
a few days ago,
at that speed for
y'all saw a flip-flop on the bottom.
a while now, so
How
it's
often
just
do you
what I'm
see
used to.
man-made trash down there? Apparently quite often.
The kids think
during our watch,
it's
I've only
scanning
so
faster,
far
they
seen
can
the
see what's
flip-flop, but
coming
according
up
to other watches
faster, but
and other expeditions before us, there's actually quite a bit of trash
we're
that we see
moving
at
it
the bottom of the
literally
ocean,
at crawling
unfortunately.
speed, and it's looking out 50 meters. So, and when it's scanning that fast, when you any turn or movement from the vehicle smears it even more. It's maybe you'd have it going that fast if you're on a boat doing 20 knots or something, but or 10 knots. The way I look at stuff, I kind of look at it every once a sweep, or I try to. Yeah, usually I can look at it and kind of get a picture of where we want to go. And when it's going so fast, I don't get the information I need, I guess.
Another question in the chat is a follow-up question. So does that mean that all life forms that don't have hard structures can't be aged without visual confirmation, such as jellyfish, sea cucumbers, and other fun, floaty, squishy guys? That's actually a good question. I believe we can date sea cucumbers. I'm not so sure about jellyfish. Kukui, do you know any more about that? Because I know that you work down there in the wet labs.
Yeah, that's a very good question. I believe we were using stable isotopes to characterize the gut contents of the sea cucumbers, but I'm not sure exactly of dating the whole sea cucumbers in of itself. I think you need a lot of material to do stable isotope analysis, but they're mostly doing genetic tracings on the tissue samples, so that is a very good question.
Most age dating, like if we're talking like radio isotope dating, like radiocarbon, we do need hard parts. So gelatinous organisms are really impossible to date or age. So there's really no way of telling how old they could be. Things like corals that leave a hard skeleton, for example, much easier. But yeah, not necessarily the gelatinous stuff, because you know those cells are constantly being replaced over time. So you have to understand that the age of it is going to be changing constantly. Much like cells in your body. You're constantly creating new cells for the old cells that die. So anything that really is dateable has to have, pretty much has to have very little to no cellular processes going on. Otherwise, the date would be wildly inaccurate.
We have a question actually about the ship. What is the difference between EV and RV? Is there a reason the Nautilus is an EV instead of an RV?
We're special.
I like to think that too. My mommy calls
And
me Fisher.
famous.
I know that ROV stands for research vessel, so I'm not entirely sure, but it could mean instead research, exploration vessel.
It is.
It is.
Oh, cool.
Nice job, Matt.
Thank you.
We are special.
Yay.
Top left of the screen, there was something. Maybe a little up in the water column.
Talking about rocks or animals here?
It looks like an animal. It's in the DSC right now. You see it?
Yeah, I see it.
Oh yeah, it's another one of those tunicates.
It's got a long anchor or whatever that is, stalk.
Well, once again, the DSC pays off.
No kidding.
Totally.
Good catch.
Nice eye, Brandon.
The rare double-headed tunicate.
Wow.
Yeah, no, I don't know if that's that's probably not diagnostic of a different species or not. It might just be a unusual growth pattern.
Still cool.
It looks like the same as shape, at least the top one,
Yeah.
as the last one we saw.
I've never seen that though. That's noteworthy.
Oh.
Kind of reminds me of like a butterfly net.
Yeah, I could see that.
Yeah.
That does.
Or like those things at the airport that determine the wind, which direction it's going in.
Yeah,
Yeah,
a
windsock.
windsock.
Windsock, yeah. Except they're ocean socks. Flow sock. There you go.
All right.
Okay.
Nice shot. All set.
Okay.
Well. Almost everything's buried right here, in terms of geology.
What a cliff.
Yeah, I wonder if it's it would be different if we were up on more of the ridges that were to our east and west. I imagine the slope would be a little bit steeper. So I think that the goal of this dive track though is to get up, come up here through the valley or canyon, gully, whatever you want to call it, up into the saddle here at waypoint 2. And I think the goal of looking at the saddle is to see if there are nodules or something like that in the saddle where they might collect and you might have current accelerated flows. And then there's a small, what looks like a cone, volcanic cone to the west at waypoint 3. So this track was chosen very explicitly to look at those 3 different characteristics possibly of this site.
Plowing.
I need to see the consistency of the seafloor though.
It's very muddy slope here. We'd like to see the do some collection.
Looks like charcoal.
Lunar, like.
Right, yeah.
Speaking of rocks, we have another geology question. If you brought up a rock from this depth, would the pressure affect it at all, or are rocks totally unaffected?
They're unaffected. They, if they do have gas within them, it is very minute.
Wow.
Definitely muddy under there. Yeah.
Wow.
Just a little muddy.
Did you say it looks like a forest fire?
I'm very familiar with that.
Yeah.
San Jose.
San Jose, California, baby.
Collect
That
some
time of
those
year.
nodules. Oh wait, we just did. This will be That mud will be with us for a while. Only we had a wide camera looking at the port.
So Brandon, how many nodules have we found so far?
A whole lot of nuttin'. Yeah, we've found some fields that look like nodule fields, but we collected the nodules and they were just chunks of basalt. So
then what do you do with those chunks?
a whole lot of nuttin'. We look at them and say, ooh, basalt.
You do cry a little bit.
Maybe in 100 years' time, somebody's going to have a method or something to extract useful data from them.
You think these are the same, just basalt?
I think so.
Only one might know for certain.
Yeah, I'm surprised we haven't taken the...
You want a scoopy?
As far as I know, the other geologists said not to collect any more scoopies until further notice.
Shucks.
No more Scoopies, aye.
But if we get down to the saddle and we see something more characteristic that doesn't look like a nodule field to me, then we can scoopy and they can yell at me if we're incorrect.
All right. I like the sounds of that. Obviously being correct. But
Like the sound of Brandon getting yelled at.
that's not what I intended.
Steve, here's a question from our friend Jason. Do you know if the stock tunicates reproduce?
Yeah, I think they're most likely. Well, I don't know about their exact reproductive mode, but yes, they are reproductive. But to the best of my knowledge, it's strictly sexual reproduction and possibly broadcast spawning. So each individual will have either sperm or egg, and they'll fertilize in the mid-water column. But I don't know about this species specifically if it is has variations on that reproductive mode. Yeah, so I mean we've seen a fair number of them, just in the past, maybe 30 or 40 meters or so, at least 4 or 5 different stalks. So I wouldn't say they're at extremely low densities here, but at least not typical for this depth.
Where would we normally find these kinds of creatures?
You can actually find these creatures, well, this genus Culeolus, all over the place. I think we've found them as shallow as a few hundred meters or so off the west coast. But yeah, I would imagine they're probably different species.
And then while we're looking at all these rocks, here's another question. Prior geologists mentioned low potassium rocks. What does that mean?
It means they're tholeidic. There's certain categories of basalt. Sort of their minor element compositions are slightly different. So if you have a Kali basalt, it means you have Kali metals in it, so you have higher sodium and potassium. But these ones are from a mid-ocean ridge, so we wouldn't expect that. We'd expect it to be tholeidic or low in potassium. I think that's what they meant. I don't want to take words out of their mouth, but that's the only thing that comes to mind for me.
So then what are the characteristics of these kind of low potassium rocks?
It's all chemical. It's you can't see it physically. I guess that's not completely true. No. Yeah, that's true. Yeah, I'm pretty sure it's not a physical parameter. Because I don't think it'll affect. It might affect mineral composition, but we can't see that here. Yeah, so like in a Kali basalt, you might expect to find more plagioclase. Where tholeidic, not so much. But we can't see that here, so.
We could probably do a push core in this stuff.
So how do you find that out? Do you cut them open, or
yes.
do you take?
Okay. Sometimes it's fine-grained, and we can't see the mineral content, so we have to take a thin section and use a microscope. which if you haven't seen igneous thin sections, look them up. They're absolutely gorgeous. I have one framed in my room.
There's the homework for our viewers at home. Go look up igneous thin section.
You might get some of that strange marine smell if we did a push core. That would definitely go in here.
Have we taken any push cores yet this expedition?
Yeah.
No.
No. Yeah, we've tried.
You would get one here, I think.
Yeah. The thing is, I don't know if we really have any use for it scientifically. There's been no requests for cores. Doesn't mean we can't use anything from them.
You don't think it would capture the whatever that
I
red
think
kind of
Liz was
flaky
talking
smell
about
is?
getting some push cores in shallower regions for her sea cucumbers.
Oh,
To
really?
compare, yeah.
Okay.
I think
Push cores
so.
from the shallows?
I think so. I may be mistaken, but
Okay.
yeah.
Well, we'll do that there in the shallows. Yeah, I mean, so with push cores, they're challenging depending on what the needs are, and oftentimes using them for one scientific purpose makes them ineligible for use for another. For example, if you were looking at that's like stratification of the sediment, or what do they call that? There's a special word for it. Anyway, like the layers of sediment.
Left here quite a ways.
You know, that would need to be preserved intact, right? Or sectioned somehow on the ship, which we do have tools to do in a pinch. But most of the time we'll send the cores back whole to the repository, so they're most useful to the greatest number of scientists who might be interested in them. But at the same time, sending those cores to a geological repository would not make them useful for biologists who might be interested in the infauna, which would require sectioning, you know, every few centimeters or so, or every centimeter, to look at patterns of biology that might be present in those layers.
Looks like a big rock, yeah.
Where'd you come from?
Quite a ways off of
Wow. You want to sample that one, Brandon?
Yeah. Whip out the battle saw, cut it in half.
I think you can fit it in a bio
Oh,
box.
is that, what is this floating on the right?
Right.
Oh,
So
yeah.
another tunicate.
They look like fishes to me.
Yeah.
They keep getting me. Oh yeah, there's some life on this rock.
Yeah, more of these sponges we collected, and tunicates.
So Brennan, what kind of rock is this?
A big one.
Thanks, Brandon.
It looks like basalt. Not a lot of crust on it. Just looks like, yeah, just a big basalt.
So with this I totally just blanked on the name. With the crust,
Manganese, it's an element, yeah.
Ferromanganese crust, is it very common to see it at lower depths, or is that more of a shallow range kind of area? Or is it just universal?
It has to do with like metal transport within the water column.
Yeah, I don't know if you're close enough to come
So I'm pretty sure it's pervasive, but it can change depending on where you are, what track in the ocean circularity circle you're in.
Bridge now.
Give it a
Same
try.
step, please. 40200. Thank you.
And then that ferromanganese crust, I know you explained it a little bit towards the beginning of this expedition, but can you give us a refresher of how it's made?
Sure. So from what we've seen, these are all hydrogenic, and that means it precipitates out of the water. And certain metals are concentrated in it. iron and manganese, obviously. Also nickel and cobalt. And physically, it sort of has this botryoidal texture. It looks like grapes. And you find it on, it can be on any rock. It can be on limestone, it can be on basalt. It can even be on the organic material. And when it's hydrogenic, at least on the rocks, it precipitates about 1 to 5 millimeters every million years.
Can I take a look at, oh, is that a dead stalk? Okay, never mind. Dead sponge stalk.
Apparently it can also precipitate diagenetically, which means from groundwater. And it can also hydrothermally precipitate. And those accumulation rates are faster than hydrogenic crust.
How fast?
From the numbers I've seen, it's about 10 times to 20 times faster than hydrogenic. I keep wanting to say genetic instead of genic.
It's okay, rocks can be alive. Not really.
Well, I mean, they kind of have genetics if you think about their source region, their chemistry, where they came from.
Yeah, I guess.
You're gonna get some angry emails from some biologists, I'm sure.
Yeah, fair.
I could already
it's
hear
okay.
them clacking
I
away
won't
at
open
the
them.
keyboard.
It's not possible to have biology without geology. How about that?
Fair point.
Geology's cool, but biology's beautiful.
All of these are debatable statements.
No. What's that red thing in the bottom? Oh, in the bubble. Looks like a cucumber or something.
So this is about the depth we've traveled at. I'm looking for another rock to pick up. But
There's one.
obviously, yeah, right. Haven't seen one yet.
Speaking of ferromanganese crust, how come ferromanganese crust is depth dependent for optimal deposition?
Ooh, look at the rock in the meso. Nice.
Is it depth dependent? Is that what somebody said?
That's what someone in chat wants to know.
I'm not aware of that.
Can we zoom on whatever those nubs are in the rock?
I can.
Roger on the nubs.
White nubs here on the between the cracks.
These ones always make me nervous. Like, how much do I have to nudge it before it topples over on top of me?
Yeah. Okay. In a way, it's depth dependent because it's dependent on seawater composition, which is dependent on water depth. So it's kind of like a second tier of dependence. So they're not wrong, but it's mostly about water composition.
Barnacles.
Wow.
Live barnacles too.
Have we seen a lot of barnacles around this kind of, on this expedition?
We've seen them here and there. They're usually associated with the fouling community, like when things get attached to corals and dead animals.
Should be able to get a tight zoom there.
Sure.
And then for barnacles, do they have any predators at this depth or anything that would prey on them?
I would imagine a seastar or other echinoderm would probably
tunicate
prey on them.
DSC.
Looks like they're feeding pretty well. They've got some big stringy mucus on their feeding appendages there.
Does that indicate health or how well they're
It's
doing?
probably good flow. Just a good flow environment through this crevice.
Bridge nav.
All right, thanks.
Same step, please. 40200.
Go white, yeah.
Thank you.
Glad we got one of those sponge samples when we did, because they're the most common large critter here next to those tunicates.
Has anyone seen those little red-looking cucumber-like things in the rubble?
Is it shrimp or is it something else?
No, it's like a deeper red, like a maroon, like a burgundy.
Huh.
I've seen a couple of them. Usually in the bubble cam, so it's a bit too late.
Now we know where those sponge stalks came from. We saw downslope.
Yeah.
The hell?
Yeah. Tough when all the lights are up above to get anything low image.
It's like correcting, kind of. It's a cool looking rock.
Yeah, those
Yeah,
like
it's-
striations are kind of cool.
Yeah,
What did we just say about geology?
it's cool.
Cool.
It
That's cool.
rocks.
It rocks. Nice.
Nice rocks.
Surprised we haven't heard that one yet.
Yeah, nice. I think most geology departments attract students to their departments using posters that say something to that effect.
Is that how they got you, Brandon? With witty puns?
Yep. When I picked my major, I was like, well, who has the best puns?
What do you think it's a close second in terms of puns in that field?
Like, which field has a close second in
Yes.
puns?
Okay, off we go.
Chemistry.
Yeah, for
Yeah.
sure, because you see
Yeah.
people use like the symbols for puns all the time.
Herc is just a pig pen at the moment. It's got all that stuff on the bumper.
Let's see, is there a loose rock here? I don't see one.
Here's a question for our ROV team. Does Hercules have a way to measure CO2 levels and ocean pH levels?
Absolutely.
Wait, what?
Wait, not CO2, sorry. Take the C out and we
Is there a
have
new sensor I'm not aware of?
O2.
we have an O2 measure.
Do we have pH? I don't know if we have pH.
I don't think so.
You can have pH.
Whoa.
Just
Oh.
it's just a
What
question
is
of
that? Yeah, bottom right?
how much effort.
Just swung out of the screen there.
Looks like a
Looked like a
Medusa
sunflower.
right here.
Yeah.
that was some sort